Do it. Welcome to today's session. This completes our GitLab story. What we're talking about is the last three stages in GitLab. So we've been just powering through them. The goal of today's session is ultimately to have better customer conversations by talking about, in particular, the manage, monitor, and defend stages, and ultimately understand what are our customers, why would they care about this, and what we're trying to do. Why did we add it in the first place, right? Ultimately, this is part of what our customers are buying. And so being able to articulate, explain it, it's just part of what they're getting, and maybe it can entice them more. So we're just finishing and rounding up that story today. So last time in GitLab, we talk about these things all the time, but developers to create merge requests. After that, all of our CI runs. After that, it really depends on the type of application. For certain applications, we'll create a new installer for you and we'll store that on the GitLab server itself. If you have a different type of application, you can update your servers, right? And so what we're talking about is cases number 2 and 3 from our last class, either creating new servers or updating existing servers. And then now answering the question of now what? Obviously, there's 3 product categories left, right? So the story continues, and that's what we're talking about today. So what's really left when we're talking about like a DevOps platform or one tool for the entire DevOps lifecycle? Well, there's still a couple of things that we need to add in. And really what we're talking about here with these 3 stages is more about like business level understanding of what's happening in my organization. So as an organizational leader, having metrics to assess the health of my organization, something that every VP, every C level, they care about. You know, how fast is my code coming along? Am I efficient? What are my bottlenecks? That's what we're talking about here. So almost like if you think about an airplane pilot flying through the atmosphere at 30,000 feet, then you know, they have to have lots of gauges. And what are your gauges for your engineering organization? That's what we're talking about for this first one. Question number 2, as an engineering organization, I need to monitor my environment to proactively mitigate risks. As anyone that's read the New York Times or the Wall Street Journal yesterday, they know that the US Commerce Department actually got hacked. It seems like it was a pretty major thing. We don't know what information they were able to get out, but worst case scenario, they learned how to print US dollars. That'd be a big problem, right? So just having metrics for security and also performance. So what we're talking about is like, do I have enough servers? Are my servers fast enough? When do I need to buy new servers? So that's what we're talking about. So I sort of conflated number 2 and 3, but long story short is that all of these higher level organizational metrics of how healthy is my organization? Am I fast? Am I efficient? Am I proactively getting the right equipment? Am I proactively making sure that everything's secure? That's what we're talking about today. And these are the manager, monitor, and defend stages. So what have we talked about so far? Well, we've talked about the previous 6 stages. These were covered in our other 200 level classes. And what we are doing out today is we're just finishing this story, the manage, monitor, and defend stages. So let's jump right in. So let's talk about the manage stage first. And really what this is all about is giving VPs, C-level, even I'd say senior director, visibility in their organization. Certain questions that it answers is, how quickly am I developing code? Like, are we fast? How are we compared to the other groups? How are we compared to my peers and my competition, right? We need to have some sort of metrics for this. Otherwise, it's just all like good. You know, someone will say, we're doing good. Well, how good? Other questions that we answer is, how often are problems surfacing? What is the quality of my applications? Is the quality good? There needs to be some sort of metric for that. How does it improve in time? Is it 20% better? Is it 50% better? We give you metrics for this. Other things are metadata on our projects. This helps with hiring and things like that. And ultimately, what are the bottlenecks in my development process? One of the themes that I'll talk about in this class is the danger of relying on word of mouth. The danger of relying on word of mouth is that if I'm some VP, I have 8 direct reports, and this happens across every team, every organization, is that there's one person that's really good at talking, is really great politically, doesn't actually do that good of a job, but knows how to work the right channels. And what happens when you promote someone like this is that everyone else who's actually doing the work, they get mad, right? They feel like it's unfair. It's bad for culture, it's bad for morale, and you're not like promoting the right people. So trying to figure out what are the bottlenecks, what are the people that actually are doing a great job. That's what we're talking about here. Ultimately, metrics are needed for leaders to accurately resolve organizational challenges. Without them, you don't have a compass, you don't have gauges, you don't have a roadmap. The reason why every single marketing, like all those Todd calls that we have, what's the first thing that we do is that we go through the metrics. Which ones are going well, which ones aren't going well. So that's what we're talking about in the managed stage. So I have a bunch of, let's actually look at the product itself. This is the first chart that I want to display. And really what this talks about is code velocity. How efficient is my engineering organization? Is it increasing in time? Is it decreasing during the summer months because maybe people are less motivated? And if it is, as an organizational leader, what sort of things can I do in my organization to increase motivation then, right? Are there spikes all the way at the end of the release? So let's just say that there's a September release and that this is a huge spike. Well, that means that code developers are usually either, I now understand that A, they're under a lot of pressure, B, they're just trying to get stuff in, and C, all of that stuff, because it's getting shoved in all at once, is probably not the highest quality, right? So knowing how to interpret these charts allows me to have better leadership decisions across my organization. So once again, this is what we call throughput. It's the number of merge requests that are merged every given month. And then what I'm looking for is, do I have any unexpected dips? Is that morale? At the end of a release, do I have a huge spike? And that usually indicates, that's a red flag to me. That means that people are just pushing their stuff through because there's a deadline. And usually I'm going to pay for it in the long run. Other things to take a look at is what we're really talking about is the idea of iteration here. So in continuous integration, continuous deployment, the whole idea is to iterate. So merge in small changes all the time. Do not have big changes, 1,000-line code change, right? And then so you need some sort of metric of figuring out, am I actually implementing CI/CD? And that's what this line change metric tells you. Well, if all of my changes are +1 line, +23 lines, +48 lines, +1 lines, +18 lines, then we're doing a great job. And GitLab in general, from our organizational metrics, we are doing a great job with CI/CD. If I'm seeing a lot of merge requests that are +600 lines, +300 lines, and the good thing on our behalf is that there aren't very many of these, right? Then that's not as good. As an organizational leader, if I really want to develop and implement the best practice of CI/CD, I have to make sure that I want to see like 18 line changes, 68 line changes. And that basically tells me I am on track into implementing CI/CD and getting, excuse me, all the business value benefit out of CI/CD. So this next chart that I'm talking about, this is more for the manager, senior manager level, but it talks about all of the outstanding merge requests, right? And what it's telling me is the amount of time that it took to review these merge requests. What I would do if I were a manager is I'm in charge of maybe 1 to 2 teams. I'm going to go through every couple of days, look at all the merge requests, look at the review time. And then what I do is the ones that are taking too long, okay, this is way too long, right? This is over 2 years. If I scroll down, then like a typical organization's not going to see merge requests that are that long. But what I'm going to do is I'm going to say, okay, the ones that are too old, we have to figure out like what happened. Was it that someone left the company? And so there's this outstanding merge request. Well, we got to get someone else to like pick up slack and to get things in. The other thing that happens is if there's a large review time is that developers are fighting on the best implementation. And that happens all the time across organizations. And so now if almost like a fight is breaking out and people are arguing back and forth, then as an organizational leader, like a manager level, I have to come in and do my part to make sure that work gets done, right? Is it getting nasty? How can we just make this about the business and get our code in, right? So what we don't want to see is we don't want to see high review time. The merge requests that have high review time, I would go in as a manager and see how I could help. That's my goal. I would do that multiple times a week. Here's issue analytics. This really talks about your application quality. So as you can see, let's just say that GitLab, the number of customer issues that are coming in for our product, it starts off, it's not very high and it keeps on creeping up, it keeps on creeping up. Well, this tells me either A, more customers are using our product, or B, the quality of our product is decreasing. So it's just sort of like there's two variables that are moving at the same time. But if for a different organization, let's just say that your customer adoption is about level, then what we have is we have a major release in April, and then we have a ton of issues that come in May, June, July. Well, we now know from a graphical perspective, well, what we did is we rushed through code in April and we're paying for it in May, June, July. So now as an organizational leader, I have a business level decision to make. Either A, I'm okay with this, okay with hiring a lot of support engineers to figure this stuff out, or B, maybe it makes more sense to not release so early, get things more solid, more tested, more vetted, and not pay for it for the next 3 months. This is like an organizational level decision. Some people, there may be a business case for releasing early, right? It could be that you have a major conference coming up and you just need to have something to talk about for your conference. That happens all the time. But this is what we're talking about here with time series data on our issues. And you can see over here all the issues that are coming in. And ultimately, this is another dashboard for your organization. Over here, we can see the severity of all of our issues coming in. So a priority one is like a really big deal. Like our GitLab server does not turn on. Our entire organization is like stuck because our GitLab server doesn't turn on and we have like an ultimate license, right? So these are the ones where it's like a support engineer, go look at the priority number ones first. I'm going to assign my senior principal support engineers for these Sev ones, right? And so now let's take a look at this undefined category. What undefined means is that generally speaking, a customer comes in, makes a support ticket, and then our engineers get to decide, is it priority one, is it priority two, is it priority three, is it priority four? So your undefined support tickets is really your backlog. They haven't been triaged yet. And as you can see, the number of undefined support tickets is creeping up and up and up for GitLab. And so now you have a bunch of questions like, one, is this okay? Is this something that as an organizational leader, we are okay with? Or maybe I need to hire more support engineers, right? To get this like untriaged issue count lower, right? And then so our metrics give us visibility into, okay, let's just say that we hire a bunch. I want to go see now this decrease January, February, March. And this is my graphical way of finding out, is the business decision that I made of hiring these more support engineers, is it paying off for my organization in time, right? So this is the dashboard to look at for that. One last chart, which developers to hire, right? So generally speaking, all of your managers are going to tell you, I want more headcount, I want more headcount. Well, not everyone gets headcount, right? So if there's one team that does all the Ruby development, there's another team that does all the JavaScript development. Well, I need to have some metrics to figure out how many developers I actually need. Otherwise, it can get really out of line, right? And so one of my gauges for that is what percent of all the code in my organization is Ruby? Well, over here, it's around 70%. So that means that around 70% of my developers should be Ruby developers. For JavaScript, it's around 20%, right? And so what I'm looking for here isn't an exact relationship between my developer percentile and what I have in this chart. But what I am looking for is that there's not a big discrepancy. If there's a big discrepancy, then that raises a flag to me as a VP level, is like, there's something that's out of line here, right? So being off 10, 20%, that's okay. Being off 30, 40%, that's going to raise some flags of just sort of like, why are we so out of line here? So I know that I just went through a bunch of charts. Let's just go through them one at a time. Throughput, how efficient is my development? Code review, can I help with any of these outstanding merge requests or my developers fighting? Issues by month, this can tell me if I'm having culture, if morale may be low, if I maybe need to spice things up during the summer months or something. It also tells me like what's the quality of my releases, right? So if I have a release in June and then a spike in July, then that's a problem, right? So we're talking to a certain extent it's normal, but if it's too high, then we're just releasing bad code, right? And our customers don't like it because it doesn't work. This one is how are my customer support tickets trending in time, right? Do I need to make new hiring to alleviate this? This last one is what sort of developers should I hire and how many of them and at what percent? So these are just like how a plane flies, and I have to have a lot of gauges for this. As a VP C-level, this is some of the gauges that I have for my organization. And so let's actually just talk about this a little bit. The only reason why we are able to give you so many great business level organizational metrics is because GitLab is one tool for the entire DevOps lifecycle. So if you had some of your CI in GitHub, some of your CI in Jenkins, some of your deploy in something else, some of your security stuff in someone else, it would be much, much more difficult to get some of these metrics just because each of those tools has a piece of that story. Because we collect metrics on your entire organization from end to end, that's the reason why we are uniquely positioned to give you organizational level metrics. We are better than this than a lot of other people are, simply because of the fact that we are collecting metrics in your entire development lifecycle. Otherwise, I would have to write some integration, make some chart, integrate it into Jenkins and GitHub and something else to create one of these like composite charts. And that's just a mess. No one wants to do that. Can I help clarify anything about what we just talked about before we jump into the monitor stage? All right, pretty clear for everyone. Cool.
I just want to add something, Chris. It's really interesting to see how you use the rest of the analytics, but actually the one that you use the most to showcase what you just said is the value stream. Is that part of what we were seeing, or is another thing?
Yeah, it's the last slide that I mentioned, and I actually forgot to mention it over here, demo organizational bottlenecks. So I need to go pull this up real quick. This is thanks for bringing it up, Bruno. Yeah, so let's talk about value stream analytics real quick. This is something that we aren't mature in, but in all honesty, if I were a VP or a C-level, this is like one of the reasons why I'd buy GitLab. And we talked earlier about the danger of relying on word of mouth. The danger of relying on word of mouth is because if I'm a C-level, I have so much stuff going on. I'm not in the weeds of any individual like group because that's why I delegate down, right? And so a lot of those people, they do rely on word of mouth. And obviously the problem with relying on word of mouth is the sample case that we just talked about. So value stream analytics can be set up to basically whatever you want it to be. In our particular instance, we set it up so that amount of time that it's in an issue before someone picks it up, after someone has assigned themselves to it, then the amount of time before like they start coding, is just the amount of time that it takes for someone to code it. At the end of it, a merge request is created. That's the event that triggers the next phase. Test is the amount of time that it takes the test phase of our CI to run, which is really quick. That's part, and the reason why is because GitLab is great at this, right? The amount of time that it takes for a merge request to get reviewed and finally merge, 7 days. Staging, we don't collect data on this, but let's just say that your environment's different. Let's just say that your environment has 3 stage categories, because sometimes you deploy to the cloud, sometimes you deploy to on-prem, sometimes you deploy to like a test environment, right? So you could have stage 1, stage 2, stage 3. And you can, this is completely customizable, but at a high level, what we are talking about with value stream analytics is collecting metrics on each of the phases in your development lifecycle. We just saw that how we do that here with GitLab. So, and how this helps with decreasing word of mouth is, let's just say that I'm an engineering VP. I got a director that's in charge um, of the testing. I got a director that's in charge of development. I got some project managers that are in charge of like creating issues and then like assigning them out, right? And they're all telling me I'm doing such a great job, right? And the fact of the matter is that like, all right, well, we just missed the last 3 releases. Everyone's blaming each other. So I now need to have some metrics to actually understand what's going on in my organization. And that's what value stream analytics go. So what a lot of people do is they'll assign like almost one business unit to each of these categories, right? So your developers fall into the code. So your group of developers fall under this category, your test QE people fall under this category, so on and so forth. Your project managers, they fall under this category. And then now I have metrics on which phase in my development cycle is my bottlenecks and which ones are my relative strengths, so that I can have more of a metrics-based performance conversation when people are asking for promotions. That's what we're talking about with value stream analytics. Thanks for bringing it up, Bruno.
Oh, thank you, Chris. Yes, like for the first questions that you mentioned in the first slide, like how fast we develop and all that, like generally that's my go-to resource to point out, like it's just
Yeah,
seems like very clear deployment frequency, deploys, and all that. And probably the quality is more based on the issues and all the other analytics, right?
yeah, exactly. And then the other thing is you want to see improvement too, right? So tell me about the last 30 days. Tell me about the last 90 days. Tell me about the last 7 days. Am I trending in the right direction, right? So let's just say that like we implemented some new organizational change. We hired some new director. He's got fresh ideas. Well, tell me about the payout, right? I got to know about the payout. And so like the ability to just like toggle through some of this stuff, this gives me time series data on figuring out, are some of these strategic bets that I'm making for my organization, are they winning? And ultimately, did I make the right choice, right? So every change for my organization, there's risk, right? We can go in the wrong direction. Are we going in the right direction? You need some metrics for that. Okay, cool. And the last thing I'd say with this is that without knowing what your bottlenecks are, then you really have very little way of improving your organization in the first place. So like Todd, when he talks about like first order net new logos, right? So it's like, if he didn't know that because he didn't have a chart, then that would severely impact our ability to win in 2021, right? Yeah. Okay, so let's talk about the monitor stage next. This is actually, let's just stop briefly. Can I help clarify anything that we went through in like the last couple of slides?
I'm good.
Okay, awesome. Let's continue then. All right, so let's talk about the monitor stage. And what really the question that this is helping our leadership figure out is, and this is more engineering leadership, not as much business value, is how do we quickly identify and respond to problems in our applications and servers, right? And so this is a little bit different. On the first question, it was almost primarily business value. This one's going to be more in the weeds. So we're talking about like VP of infrastructure, right? This is the type of things that he cares about. So questions like, how quickly do my engineers identify, diagnose, and respond to application issues? So creating that support ticket, figuring out the answer to it. How fast is that? If it's for a good organization, maybe like 1 to 2 days. For a bad organization, maybe a couple of weeks, right? So I got to have some metrics on when someone raises a support ticket to when we get like a response and know what's going on and we're on our way to solving it. Like we need a metrics for that. How do my managers make sure that our applications have enough resources, right? So enough servers, enough CPU, enough memory, enough like are our websites too slow? Like, are they fast enough? We need to have metrics for this. If we're Amazon.com, so like for many of y'all that took our earlier sessions, you know that the difference between a fast website and a slow website is maybe 50% in sales. So for Amazon.com or Netflix, there's absolutely absolutely need metrics for figuring out like how fast are your websites? How is this trending in time? Are we okay during the holiday session? Are we okay like on a 3-day weekend, right? So that's what we're talking about here. So we include powerful tools to bootstrap this process. And one caveat that we have with this is that most of the features that we're talking about here, they work for Kubernetes-based environments. So that's the caveat. So to really start talking about what we do around this, it's important to understand how normal people do this without all of these tools. And I used to be one of these people, right? And so just a little bit telling this story, I was a test engineer for half a decade, and every server that you have has maybe around 10 to 15 log files, and these are just these gigantic files of text. And it's just sort of like if you create a new folder, it's logged. If someone logs in the system, it's logged. And so to solve an issue, you're basically looking through these massive files trying to find out like, oh, there was an incorrect system call at time 2018 09 06. This should have been something else. It's very, very, very specific, looking almost for like a needle in a haystack, right? And another thing is that when a problem happens, you get this thing called a stack trace. What a stack trace is, it basically is the computer's way of saying something bad happened. What happened? A 500 happened. Why did it happen? It happened because of this. Here's the, if you look at the code here, then it tells you basically exactly what happened. I wouldn't say exactly what happened, but pretty close to it. And so customer issue comes in, then the number one thing that you need is you need log files, which will tell you what was actually happening on the server. And if you can get a stack trace, that also helps you. You need this information. So what's the problem? The problem is that looking through all these log files is really, really hard, right? Each server may have 10, 15, 20 log files. And let's just say that you're Netflix. You don't have 10 servers, you have 100,000 servers, right? So how do you want me to log into one server, look through all the log files? These are 5,000 pages of files, log back out, log in the next one, and then eventually I find the server where the problem happened? Like, it just doesn't scale, right? The other problem is that some problems are very difficult to trace. So what I mean by that is that if you just think about like how complicated technology is, and this is a fake example, but it's almost to illustrate it, but it's like, why was I in such a bad mood today? Well, the weather's really bad today in Raleigh, and something else happened, and I'm stressed out because of Christmas, and I didn't get a promotion. I don't know, something like that, right? But it's like 10 things lined up, and then some bad outcome happened. It's the same thing with servers. So it's literally like 10 people tried to log in. We only wrote the code for having 3 simultaneous logins, and then this other thing happened where our load balancer did this really weird thing that only happens during an update, and the update was happening at this specific time, and then this specific user got an error message, right? So it's just really, really, really hard to trace. But the problem is that it's just sort of like your job is to figure this stuff out, right? Because if people don't like your product, they run into these problems, then ultimately less people are going to buy your things because those people are going to be vocal and they're going to tell other people to not buy your product. So ultimate problem is that this ultimately creates situations where quality engineers, they report a problem, and developers, they deny it. So now you have like this situation where like quality engineer comes in, does 2 weeks of work, maybe literally like 60 to 80 hours looking through all these systems, creates a report for the developer to go fix something. Developer says, I don't see this on my system. I don't know what you're talking about. I'm not going to work on this. So how often did this happen when I was a quality engineer? I would say maybe in a given year, I'd say maybe 20% of the time. Out of all of the support tickets that I went through as a quality engineer, developers would like say, I don't like, they basically deny it maybe 20% of the time, right? And then ultimately what happens is that now you have deadlock, there's no progress that's made, And all the while this is happening, the customer is not happy, and also the team's not happy, right? So all this is to say is that, long story short, it is hard to be a quality engineer. It is hard to accurately diagnose a problem. Without an accurate diagnosis, developers don't know what to do. Sometimes they purposely don't know what to do because they don't want to work on stuff. And then it ends up into very nasty situations a lot of the time. And so there needs to be some better way of doing things. And so what we're talking about is ultimately paid tools for monitoring your servers, right? So let's just say that we're looking for something like this in a stack trace. Well, as opposed to me manually logging into each server and looking through all these servers, what if I had some sort of third-party like machine that was monitoring all of the log files for all of the servers in my environment? That's what we're talking about here. And that's actually something that GitLab does. So what we do is we can monitor your log files for you and report errors as they occur. That means it's all automated. I don't have to have some QE person log into the machine and look through this 5,000 page block of text and try to figure out like when the mistake happened, right? So immediately as the mistake happens, because GitLab is looking at your log files in real time, it can basically automate the creation of an issue. And then, so the reason why this is good is because, one, this saves QE a lot of time. Two, this is an objective source of reporting to show developers. So it's not like this argument where it's like a developer is trying to say something and it's not getting through. Now all of a sudden GitLab, which is a robot and is a like all automated solution, has reported this. So it's hard to really argue with like what our tools are saying, right? So we have automated creation of issues as errors surface. As soon as that server problem happens, as soon as that stack trace shows up in our log file, then we'll create an issue. And then a customer, like a support ticket can come in, go to the issues list, go to the support board. So this is all fake. This isn't a good example, but like it will create an issue for you. Say what happened, what server, what log file, when, and now all of a sudden it basically automated a lot of the stuff that I used to do by hand. This would have saved me a ton of time if I had this in my environment. And let's talk about some of the business value that we get out of this. So reducing developer / QE friction, so that those like nasty situations they're talking about, and ultimately automating some of the quality engineer workload. This isn't really so much of the thing where it's like we have to be afraid of automating away people's jobs. The people who actually do this stuff, they really want some sort of solution that is going to allow them to do this better. Because as someone who used to do it, it was a pain in the butt to go through all these servers, look through all the log files, spend maybe 4 days trying to recreate a situation so that it happened, only to create some issue that then the developers, they don't agree with, and then they don't even do anything with, right? So yeah, like I would have really, really appreciated having some sort of third-party system to automate all of that stuff. Okay, and ultimately what we're talking about here, actually this is different. Sorry, different slide. The other type of environmental metric that we really need to keep track of, and I alluded to this earlier, is how fast is my website performing, right? And then so on the bottom here is annual financials for Amazon.com. 5 years ago, they were 100 billion. 2019, they're at 280 billion. They're around 400 billion now, right? And so let's actually take a look at some of these things. So some just like studies. Pinterest, some business increased new customer signups by 15% after it reduced wait times for their website, made the website faster. British Broadcasting Corporation found that they lost 10% of users for every additional second their site took to load. So basically, when all of your revenue comes from displaying ads, you are losing 10% of your customer base because your ad revenue, that's how you make money if your tech isn't fast enough. Google found that 53% of mobile website visits were abandoned if the site took longer than 3 seconds to load. all that is to say is that imagine a 5, 10, 15% reduction in customer adoption for Amazon.com, how much that would affect their business. So we're talking about this growth rate is 60 bill. To not invest in your servers and to create a slower speed may actually reduce that 60 bill to 55 bill, maybe 50 bill increase, right, of new adoption. That's what the data shows from all of these industry metrics. And so it makes a lot of sense for Amazon, Netflix, all of these other sites to really invest in their technology, make sure their stuff is as fast as possible. So how does GitLab actually do this, right? Well, before we jump into that, let's talk about what we need to do to like get this to work. So at a bare minimum, we have to make sure that we have the right number of servers, right? So maybe we need to buy new servers, right? And then sometimes you need to address a more specific bottleneck. Well, you don't actually need more CPU and memory. Maybe you have a network bottleneck because people are downloading too much stuff. So you can basically increase network by itself, maybe buy more wiring, bigger wiring, more wiring systems, as opposed to just putting in more servers, which isn't going to solve your problem. So, and ultimately what we're talking about here is we need a tool to monitor our environment so our business can proactively identify and respond to when more resources are needed. Is this something that, my guess is that this very rarely does this come up in y'all's customer conversations. Is that correct?
Sorry, Chris, can you repeat the question? What subject comes up in customer conversations?
Do y'all talk about this in your conversations? My guess is no.
I don't get this.
Rarely.
Yeah.
This is normally like solutions architect, infrastructure, how to set things up type of, like that's farther down the line.
Yeah.
Sometimes, yeah. No, sometimes we don't even know we have CI, so we don't get to talk about monitor, never.
Yeah, it's a good point. Yeah, so we can go through some of the session pretty quickly then. And let's talk about how we do this. We do this with this thing called Prometheus, and you get this really awesome dashboard. It tells you CPU usage, memory usage, network usage. It gives you time series data over here. And then so if customers are complaining, hey, your app is really slow, now I can go log into Prometheus and say, oh, wait, we ran out of memory at that point in time. That's why it was slow, right? And then so now we have a system to basically sort of make sure that we are doing our part as a business level leader to make sure that we are in like that elite tier of website load times, which ultimately is going to drive revenue for my business. That's what we're talking about here. One caveat about Prometheus, Prometheus is really for Kubernetes. So if you hear Kubernetes, you can talk about it. We have a lot of stuff that makes this easier, but we're not talking about like stuff that runs outside of Kubernetes. Yeah, there's some additional things that I want to tack on here. So we already talked about resource monitoring. Some additional things that I haven't talked about is automated alerts, right? So let's just say that we're having a spike in customers using our servers. We're about to run out of memory. We need to go do something quick. Well, we can actually customize when alerts are sent. We can send a Slack message to your director of infrastructure that like, hey, our app is about to run into some performance problems. You need to go create new cloud servers and get this fixed, right? So that's one of the things that another thing that we do. And ultimately what we're talking about here is that Prometheus is pretty good. There are better solutions for a lot of the things that we talked about. And some of the things that you may hear is Heroku and New Relic. These are like really, really, really big businesses. And just like how we are quarter circle in some of these things, they're like the complete circle, right, in the maturity page. All right, so let's actually just bring everything home. So who actually read about what I talked about with the hack of the U.S. Commerce and Department?
I did. It's crazy.
Yeah, it's really a big concern. I actually have a, what did you read about it, Josh? What are some of the things that you're thinking about with it?
Well, I mean, there's still a lot we don't know about what happened, but I mean, it's a significant breach likely from Russia. So I've already seen like a couple of my colleagues on the intelligence community side of things, like sending out emails to customers saying like, saw this happened, like kind of drawing their attention to our security offerings and whatnot. So
Yeah. Cybersecurity is something that I've spent a lot of time researching and reading up on because I think that in the next 10 years, this will be one of the defining issues in our age. So I'm not talking about like some small thing that technology like changes something that people don't even notice about. I think that identity theft and cybersecurity is going to redefine our planet in the next 10 years. So what we're talking about here is, let's just talk about some metrics. What did actually the analysts say? Well, the analysts say that by 2021, cybercrime is projected to hit around $6 trillion globally. That is more money lost than all of money in drug trafficking, all of money in violent crime. And basically what we're talking about is that cybercrime is going to be pretty much like, let's actually show you. So to put this into reference, that is more money than the vast majority of economies in the entire planet generate. So like France, their GDP is around maybe like 2 trillion. So there's more money lost as a wealth transfer for cybercrime than all of the economic output of France in 2021. That's what we're talking about. So it's a really big problem. From a business perspective, everyone's read about like lawsuits. These are becoming more and more common. Even the US federal government was hit. We just talked about that. The worst case scenario is that Russian hackers learned how to print the US dollar. It's theoretically possible. If that's the case, then our currency could collapse. They're real issues. And it requires like the smartest people on this planet to figure out something new because the current paradigm is not working. So what we're talking about, just finishing out this story, is the protect stage, right? We have some very limited defense capabilities. Out of all of the product stages that we have, the protect is probably the least mature out of all of them. And what we're really talking about here is server defense. When we talked about the security stage, we were talking about scanning your merge requests for problems. What we're talking about here, and why this is a separate stage, is that this is going to defend your servers that are running actual web applications and things like that. So that's why it's two separate stages and how we split them out. So it's definitely not mature, but if you're SMB and you don't have anything, it's definitely better than what you're doing right now. Obviously, if many enterprises, they have 100, 150 different security tools. They're not going to be super interested in this stuff. But the way to think about it is that if you don't have anything right now, then it's way better than not doing anything. And to have it all in one in GitLab will ultimately save you time, money, one development panel, one less tool to evaluate, one less license costs. So it can definitely be something that people are interested in. And so what we're talking about here is another theme is that most of our defend capabilities are limited to Kubernetes clusters. So if our web servers are running in Kubernetes, that's what we're talking about. And we have certain features for defending the clusters themselves, and we have additional features for defending specifically web apps if they're running in Kubernetes. So let's talk about what we're talking about here. So this roadmap, another caveat is that this roadmap is changing all the time. So some of these slides may actually be out of date, but when I made this presentation about a month and a half ago, this was our current offering. Offering number one, we have a Kubernetes cluster. So each of these is a server, right? This is a server. This blue thing's another server. And what we're talking about here is that out of our server comes out network data, right? So like when someone's accessing our website, we're giving out a HTML fragment, and then that's how someone accesses our website, right? So what we can actually do is we can monitor all of the data that goes out of each of these servers. And so if I can now put up some sort of thing that's monitoring all the web traffic that's going out, and it's like HTML fragment, good. HTML fragment, good. SSH key, that's unusual, right? Like someone's username and password, that's unusual, right? And then so that's what we're talking about here is monitoring the network traffic that's leaving your servers, also monitoring the network traffic that's going between the internals on each server. So like, not to get too granular here, but it's just sort of like if you imagine under the hood in your car, there's all these pipes, stuff's going around. I can monitor whether or not like the right stuff is going from like one component in my server to another, right? And then if I can put up like a lot of watchers, then I can figure out like, hey, this is unusual, maybe I should block this thing. That's what we're talking about here. Second thing that we're going to talk about is firewalls. Firewalls is something that we've all messed around with, and then we've had to customize. But the whole idea is that if you have a web application running in Kubernetes, then we have this thing called mod security. And what that does is it's specifically going to, you can basically say like, hey, I want to only have my app serve the United States. If it comes from like, you know, these IP addresses that are associated with like some like country that we're at war with or something like that, then we want to block all that stuff. I'm trying to like not get too political here, but like we can block IP addresses by the country that they're from. We can block specific IP addresses if there's some customer that's like, it's a DDoS attack, right? So I'm just going to hit GitLab SaaS 10 million times and try to degrade its service. I can block their IP address. So that's what we're talking about here is basically can be blocked by country, can be blocked by specific IP address. And that's another way to protect your web applications. So rounding everything out, thanks for attending today's session. I'll stick around for another couple of minutes if I can help clarify anything. If you want credit for this class, fill out the test, which I'll generate at the end of this session. But thank you all for coming. I hope this was helpful.
Thanks, Chris. Yeah, of course.
Thank you,
For
Chris.
sure.
Thank you very much.